Okay, let's deep dive into the Gaussian distribution. The way we denote it is there's two parameters. These are the parameters. Mu is the mean, and sigma square is the variance, but sigma is the standard deviation. And this is the probability density function fx. It's quite a complex function, and we'll probably use it a lot. There's actually a lot of random systems that can be described by the bell curve. And if you wonder why that is because there is a law called the central limit theorem. And that basically says that if you have a lot of random processes, they don't need to be normal or Gaussian distributed. But if they all come together and you add them up, they result in a bell curve. So the central limit theorem is something we will see in one or two videos. Contributes to the fact that you will see a lot of Gaussian stochastic processes in this world. If you take mu plus sigma, you probably have 68% of all the data. You know the sum minus infinity to plus infinity of f of x, and dx, right? dx equals 1. So the surface under this curve is 1. So if you take mu plus 2 sigma, you have already 95% of the data. And if you take mu plus 3 sigma, you have 99% of the data covered. There's one special case, is the normal distribution, which basically says that the way we note it is like this: 0 mean and sigma squared equal to 1. So the mean is 0 and the standard deviation is 1. The way we do this is we scale the features. Sometimes we do this in machine learning. It's a good practice to do feature scaling or feature normalization. So basically what you do is you subtract the mean from your point and you divide by the standard deviation. That's how you normalize.